Okay, Assalamualaikum. In this lab, we will be studying the clipping circuits, which are also called limiting circuits. Uh, for the time being, this information is enough. I will teach you all about the limiters and clippers in the class. Now, let's move toward the practical section of the lab. What we are needing in this lab is oscilloscope and a TMM resistor of 2.2 kilo ohms, a silicon diode, and a germanium diode. Unfortunately, we don't have a germanium diode in the lab, so we will be taking silicon diodes and a 1.5 volt DC power supply and its holder, DC cell. But we have a DC power supply, so we will use the DC power supply instead of this. Okay, let's move towards the practical. Starting with the threshold voltage, I have already told you that it is the forward drop of the resistor of the diode, sorry. And we have all I have also told you multiple times that how we calculate or how we measure the threshold voltage. uh, let's measure it again only for the surety. What we will do, well, it's written that if the diode checking capability of characteristic is unavailable, assume Vt is equal to 0.7. But we have the function in the multimeter. We will press the diode button and de-energize the circuit. And we will connect the positive probe with the positive of the diode. Which one is positive? I have already told you that the terminal where the gray band is present is the negative terminal and the other is positive. So I will connect the leads this way: positive with positive, negative with negative. We will have the threshold potential, which is approximately 0.46. Okay, you will note down this value here on the V threshold potential. Now let's move toward the construction of the circuit. So as you know, we need a 2.2 kilo ohm resistor, a diode, and a DC power supply. So I have this instead of DC power supply, and I have like set it on 2 volts. And I will make this circuit. I guess you people don't have any problem in constructing this circuit. Well, I am telling you again that this is a 2.2 kilo ohm resistor, and in series I have connected the diode just like the circuit in the manual, and then the DC power supply. This positive here and negative with the diode. See, negative of the battery is with the positive of the diode, with the P side of the diode. See, and then the function generator. As you know that this whole uh, um, row number 26 is a short, so internally shorted. So if I connect it anywhere in the holes, it acts as the same node. So I have provided the AC power supply through the function generator via this probe, which leads you to the function generator. So it says that set the function generator to square wave and 8 peak to peak value. What we'll do is we will simply push this button, press this button, and select the type of wave that we need. Say it's triangular, sinusoidal, and square. We need a square wave of 1 kilohertz frequency. We will press 1 and then the kilo button. Now for adjusting the amplitude, we have this knob. I have connected this with channel number 2 to adjust the required frequency and amplitude. Okay, so as the blue trace indicates that you are using the channel 2, so let's check whether the incoming wave is of 1 kilohertz frequency and 8 peak to peak or not. So I will press my ear. We have the values here on this column, which is 8 peak to peak, that is the required peak to peak value, and frequency is 1 kilohertz. So I have set the input. Now I will connect this input to this, and to get the output I will connect the oscilloscope across this battery and a diode. So I have done the same. This is one terminal of the diode of the oscilloscope, and this is the second terminal, and I have connected it across diode and the battery. So and this oscilloscope and this probe leads to the channel 1. So there is one difference, that in the manual it says 1.5 volts, but I have set it to 2.0 volts because it was unstable at 1.5. Now let's turn on the